This lab is an example of broken access control, and the title of the lab is Multi-Step Process with No Access Control on One Step. Let's take a look at the lab guidelines. This lab has an admin panel with a flawed multi-step process for changing a user's role. You can familiarize yourself with the admin panel by logging in using the credentials administrator admin. To solve the lab, log in using the credentials Wiener Peter and exploit the flawed access controls to promote yourself to become an administrator. So we're given the administrator credentials just to explore the mechanics of the lab, but the objective here is vertical privilege escalation. We want to take a regular user, Wiener, and escalate his privileges to that of an administrator. All right, without further ado, let's access the lab. So the first step here is to log in with the administrator provided credentials, administrator admin, and notice that there is an admin panel. And on that admin panel, we have the ability to upgrade and downgrade users in terms of administrator privileges. So if we take the user Carlos and choose the option upgrade user, we then get confirmation box. Are you sure? Yep. We now see that Carlos has been promoted to an admin. Notice there was a little bit of a multi-step process there. So we actually asked to upgrade Carlos. A HTTP request was dispatched in the background. Then once it's returned to the page, we then get the confirmation dialog. Are you sure? Yes. From there, a second HTTP request was dispatched. Now, how do I know that that process involved two HTTP requests dispatched to the backend? Well, I can see them here. First, post request to /admin roles. And we can see the request body, username equals Carlos, and action equals upgrade. But then shortly after, notice a second post request. Very, very similar, apart from we have an additional parameter. Action equals upgrade and confirmed equals true and username equals Carlos. Note as well that aside from the additional parameter, these post requests are completely identical. They're both posting into /admin roles, simply that the second post request has confirmed equals true. Okay, the next step is to log out and see if we can replicate that as a regular user. Let's log in now with the credentials Wiener Peter. And the main thing that differentiates a request from the admin compared to the request from a regular user is simply this session token. So we're going to send this request to the repeater, but we're going to swap the session token out with that we're given for our current login with the user Wiener. So let's copy Wiener's session token. Let's head to the repeater. Let's swap out the admin token with Wiener's token. Now let's start with the initial step before we had confirmed equals true. So I'm going to delete that from the request body. I'm going to replicate the initial part of that two-step process where we send a post request to admin roles with the parameters action equals upgrade and username equals, we'll change that to Wiener because the objective is to privilege escalate Wiener, not Carlos. So what happens when we send this post request from a user that's not an administrator? Let's click send. And we get the response unauthorized. So what is that unauthorized based on? It's based on the session token. In other words, this first step of the process is protected. What happens now when we add the confirmed equals true? Let's resend. We get a 302 response, which indicates page found. And sure enough, when we load up the lab, we get the message, congratulations, you solved the lab. So that request went through, even though it was clearly not from an administrator. So what's just happened? Now, we don't know exactly what's taking place on the back end, but if I were to guess, I would say it's very likely the following. There is some type of authentication check on the back end to make sure the session token belongs to an administrator. But that authentication check happens after a piece of logic which checks to see if the confirmed equals true parameter is set. In other words, something like this. To write a little piece of pseudocode, we can say if confirmed equals true, process command, escalate privileges, else authentication check. So the first time we post into that route, confirmed is not true. We jump to the else block. Authentication check. You're not authorized. You're a regular user. You're not administrator. Second time we post in with the confirmed equals true parameter as part of the request body, logic goes like this. If confirmed equals true, well, confirmed is true. Let's process the command. No authentication check, bypassed. So you can see out of those two steps, one is secure, the other isn't. Now that's just one example of something that may have taken place on the back end. It's also possible that depending on whether that confirmed equals true is set, that we're actually sent to two completely different blocks of code, and the developer simply forgets to check the credentials on that second step. Why? Because they've already checked the credentials on the first step. it might not occur to them that they also need to check the credentials on the second step. Because what we've done with our post request is we've jumped straight to the second step. Developers might not even be aware that you can necessarily do that. Developers don't necessarily think about these things in the same way as a penetration tester would, for example. They might think, well, you can only get to the second step if you've done the first step, and you need to be authenticated for the first step, so the second step is automatically secure. Well, it's clearly not. We just jump straight to the second step. So that's a second example of something that may have gone wrong with the backend. Key takeaways: make sure all requests that come from an administrator are protected and require the administrator's session cookie. We don't want to protect some routes, assuming that the user needs to go through those routes to reach other routes that are not protected. We need to just protect all of the routes that have access to sensitive functions, no matter what. If you do that, then your web app is going to be a lot closer to being secure. Another key takeaway here is make sure you get your authentication logic in the right order. Probably the first thing you should be doing is making sure the request is authenticated. We don't want to be processing backend logic and then, as a by the way, hey, let's just make sure you are authenticated. It's too late at that stage. We do the security check first, then we perform sensitive functions on the backend. All right, hope it was helpful. Thanks very much for watching, guys. Catch you in the next lab.